Okay, here we go again. In this video, we're going to cover absolute values evaluating algebraic expressions. We're going to be using substitutions and following orders of operation. So let's check out our first example. In example 1 here, we're going to be substituting in a positive value whenever we see x. In this case, x is equal to 6. So let's check out this absolute value expression here. So the very first thing we really want to do is copy down every single component except the x component and draw parentheses where the x belongs. So inside this x value here, we're going to substitute in the value of 6. So then we have as follows: the absolute value of 3 minus 6, close absolute value minus 5. So under order of operations, we need to do parentheses first. And since absolute values are treated as parentheses, we're going to clean the stuff inside here. So we have the absolute value of 3 minus 6, which will give us negative 3. Then we bring down the 5. So then we have the absolute value of 3, negative 3, which gives us positive 3. Then we're going to bring down the negative 5. Then in the last step here, we're going to find subtract. We have 3 minus 5, giving us negative 2. And so that's the end of example 1. Okay, in example 2, we're evaluating with negative values. So we're evaluating the following absolute value expression when y is equal to negative 7. So essentially what we want to do is exactly what we did in example 1, where we copy down every single component, draw parentheses for where we're going to do the substitution, and then perform the substitution. So inside this parentheses here, instead of a y, we're going to replace it with negative 7. So we're going to remind ourselves to follow orders of operation. So that indicates that we need to simplify what's in the parentheses first. So inside here in the parentheses, we have some subtraction involved and multiplication. So the next thing we need to do is multiplication. So we're going to copy down the 6. Then we have negative 2 times negative 7, which will give us positive 14. Then we keep carrying down the negative 5 because we haven't finished the parentheses inside the absolute values. Then we continue bringing down the absolute values. Then we have 6 plus 14, giving us 20. Then we continue carrying out the negative 5. Finally, we can perform the absolute value. So we take the absolute value of 20, is giving us 20. Then we continue bringing down the negative 5. So now we have 20 minus 5. So in the end, this is going to be 20 minus 5, or just positive 15, which will be our final answer for number 2. What we do want to note, though, is some common errors when evaluating with negative numbers. So here in the very first step, we want to be very careful when we're talking about the thing inside the absolute value. So if we were to write down each quantity and the substitution without the parentheses, then this would be incorrect because it would read as 6 minus 2 minus 7, which would end up giving us the absolute value of 6 minus 2, which would be 4. Then we have 4 minus 7, which end up being negative 3. So this is a very common error when we're evaluating with negatives when we perform the substitution. So this is something we want to be very careful about, and this is not the same thing. They do not equal each other. And that's it for number 2. We're going to continue now with the next problem. In example 3, what we're going to be doing is evaluating with fractions and with decimals in a double absolute value situation. So what we're going to start off with is what we did in the previous examples. What we want to do is indicate where we're going to substitute with parentheses and copy down every single other component. So we have as follows. And inside the first parentheses, we're going to substitute in the value of g for 5 over 2. And in the second set of parentheses, we're going to substitute h for negative 0.35. So we have to remind ourselves the first thing we got to deal with is parentheses again. Since absolute values are treated like parentheses, we're going to have two sets to take care of. We're going to take care of this first set of absolute values. Then following, we're going to have a second set of absolute values to take care of. Once those are completed, then we can finish off the problem by subtracting. So in the first set of absolute values, we just want to remind ourselves, well, in order to subtract fractions, we need a common denominator. So I'm just going to quickly rewrite the first fraction with a common denominator of 10. So I'll multiply top and bottom here by 5, which gives us 25 over 10. I'm going to multiply top and bottom here by 2, which I'm going to end up subtracting 4 over 10. And so inside this first absolute value, I'm going to subtract 25 by 4. So this leaves us with 21 over 10. I'm going to bring down the subtraction symbol because we haven't done any subtraction yet, because we still got to take care of the other absolute values. In the other absolute values here, we have to be careful about the double negative. So we're going to have a 6.3 plus 0.35. So inside the second set of absolute values, we're just going to be ending up with 6.65. So now we want to simplify each absolute value. So the absolute value of 21 over 10 is still the same thing as 20 over 1 over 10. We're going to continue bringing down the subtraction symbol. Oop, there we go. And then we're going to now take the absolute value of 6.25, which is actually still 6.25. So what we have now is a situation where we have a fraction in the first situation, then we have a decimal in the second one. So what I want to just do is either convert both of them to be fractions or have both of them as decimals. Since it's easier to rewrite the first one as a decimal, so 21 over 10 is the same thing as 2.1. Then we're going to finally be able to subtract with 6.65. Okay, so to watch out for any errors, we'll just do some quick side work off to the side here. Really, what we have is 6.65, and then we're taking it away by 2.1. So what we end up with, we're just going to have, well, we bring down the 5 here because we're not subtracting anything. 6 minus 1 gives us 5. Put it on our decimal place. 6 minus 2 gives us 4. So that our final answer is just going to be a negative 4.55. And there we go. We've done a substitution problem where fractions and decimals are involved, including double absolute values. Want to remind ourselves that we're going to simplify each of the absolute values before we do any subtraction. And that's how this one's done. So in our fourth problem, we're going to be evaluating with parentheses and absolute values involving negative quantities and positive quantities. So we're going to continue with the same pattern we've been doing in the previous problem. We're going to copy down each component and indicate when we're going to substitute our values as follows. And there you go. So in the first set of parentheses, what we're going to do is substitute in the negative 7 for the j component, and we're going to substitute in a positive k in the second set of parentheses. What we want to be thinking about is saying, hey, in parentheses and absolute values, they both follow the same set of order of operations. So that indicates that we need to focus on working from left to right before we take care of any additional negative symbols. So in the first set, we have the parentheses, and we're going to have, well, 5 plus negative 7, which is essentially the same thing as 5 minus 7, which will give us negative 2. Then we're going to continue copying down operations that we haven't done yet, our absolute value bars, then simplifying what's inside this absolute value, which is 1.5 minus 3, which give us negative 1.5. So now we can start taking care of this parentheses and the negative in front. So what this really says is, well, what's a negative times a negative? Well, this will give us a positive 2. We have to bring down this subtraction symbol before we can do anything else, because we still have to simplify the absolute values. So this absolute values of negative 1.5 will give us a positive 1.5. So now what the problem really says is, what is 2 minus 1.5? Oh, this is a nice and easy problem. That would just give us 2 minus 1.5, which will just equal to 0.5. And there we have it. For this problem, we just need to take in count for the parentheses and absolute values, follow the same set of orders of operation, meaning we're strictly going to work from the left side to the right side, and slowly bring down each of the negative symbols according to orders of operations. And huzzah, that's it. We've done evaluating with absolute values.